nucleophiles, and living groups. First, I will explain about nucleophiles. So what is a nucleophile? A nucleophile is a reagent that seeks a positive center. It is typically a Lewis base which is electron pair donor of neutral or negative charge. So from here, we can know that there are two types of nucleophiles, which are neutral nucleophile and negatively charged nucleophile. Where does this word come from? Actually, nucleo means nucleus and phile means loving. It is from a Greek word which is philia. When a nucleophile reacts with an alkyl halide, the carbon atom that's attached to the hydrogen atom is the positive center that attracts the nucleophile. This carbon carries a partial positive charge because the electronegative hydrogen atom pulls the electron of the carbon-hydrogen bond in its direction. Now I will share with you the examples of the negatively charged nucleophile and neutral nucleophile. I will put the negatively charged nucleophile on top and the neutral nucleophile at the bottom. The negatively charged nucleophiles are OH-, CH3O-, and NH2-, right? And the neutral nucleophiles are H2O, CH3OH, and NH3. For me, I only memorize the negatively charged nucleophile only because if I add H to each of the negatively charged nucleophile, it will immediately be a neutral nucleophile. Do you notice the similarities between them? Each of them have lone or unshared pair of electrons. Now, let us look at two examples. The first example is when the nucleophile is negatively charged. When a nucleophile is negatively charged, it will result in a neutral product. This is because the formation of the covalent bond between the negatively charged nucleophile with the substrate neutralizes the formal negative charge of the nucleophile. The next example is when a hydroxide attacks a bromomethane. So this is a backside attack, and when the reaction happens, the OH will replace the Br, and we will get a product which is methanol and a leaving group which is a bromide ion. For this example, the nucleophile is negatively charged, and when the nucleophile attacks the bromopropane, the nucleophile will replace the place of Br, and we will get the product as well as a leaving group which is a bromide ion. Second example is when the nucleophile is a neutral nucleophile. When a neutral nucleophile is used, it will result initially in a positively charged product. The neutral nucleophile gains a positive formal charge through the formation of the covalent bond with the substrate. A neutral product results only after a proton is removed from the atom with the formal positive charge in the initial product. The next example is when ammonia reacts with an alkyl halide. So if ammonia, a neutral nucleophile, reacts with an alkyl halide, it will result in an initially positively charged product. And it can only be a neutral product only after the proton is removed. The next example is when a dimethyl sulfide reacts with a methyl iodide, and for the product we will get a trimethyl sulfonium with a leaving group which is an iodide ion. For this example, the ammonia will attack the ethyl iodide, and the NH3 will replace the place of I, and we will get the product as well as a leaving group which is an iodide ion. To summarize, when we use a negatively charged nucleophile, we will get a neutral product, and when we use a neutral nucleophile, we will get a positively charged product. But it can be a neutral product only after a proton is removed. Now, I will explain about leaving groups. To act as the substrate in a nucleophilic substitution reaction, a molecule must have a good leaving group. So what is a good leaving group? A good leaving group is a substituent that can leave as a relatively stable, weakly basic molecule or ion. Here are some examples of leaving groups. Halide anions are weak bases, and therefore halogens are good leaving groups. Some leaving group departs as neutral molecules, such as molecules of water or an alcohol. I will show you an example where the leaving group departs as a water molecule. For this to be possible, the leaving group must have a formal positive charge when it is bonded to the substrate. When this group departs with a pair of electrons, the leaving group's formal charge goes to 0. So that is all from me for the nucleophiles and leaving groups subtopic. I hope all of you understand, and thank you for lending me your ears.